Hey going guys, Curtis from Cutting Edge Engineering. Today's job we're going to be making a pair of heavy duty button tool holders for our big lathe. So if you've been watching our videos for a while, you'll know I love using button inserts or round inserts for removing weld off components like barrels and rods in order to separate them so they can be repaired. They're also great for doing weld prep and just bulk material removal. Because they are so robust and heavy duty and versatile, they are just a great tool to use for those sorts of jobs. But one of the ongoing problems that we have is clearance between the tool holder and the job. Because of the size of the components that we do, it is quite difficult to be able to machine all the way to the base of a weld joint. The tool holders just don't have enough length in them, and the manufacturers only make them to reach a certain distance. So the standard working depth of a tool holder is about 35 mil, and when you're talking a 230 mil diameter rod, that is just not enough. So I have modified tool holders and machined a relief in the side of them so I can extend their working depth, but that only gets me so far. So we're having to slide the tool past its point of where it works comfortably in order to reach those depths, but that causes vibration and rigidity issues. So then I have to take relief cuts on either side of the tool in order to give it clearance to get deeper, to get to the bottom of the weld joint. Any material that I have to remove from the component I'm trying to save, I then have to put back by welding it. So that creates extra work, which means extra time. And as you can see, the tool holders do suffer quite a bit of damage. Because of the clearance issues, they end up contacting the job, which damages the holder. So I thought it was about time we made our own tool holders to eliminate all of those problems. And our new shop-made tool holders are going to have a working depth of 115 mil. So the material we're going to be using is Biz 80 high tensile plate, and I've had that plasma cut to a rough profile of what we need. And we're going to be machining those to a 32 mil tool height, which will suit our big lathe and our frontline Toolmaster lathe. Before I get them set up in the mill, I am going to take them over to the linisher and remove any of the surface rust before we get them set up. Now that we've got that set up, I'm going to go through with a boring head that I use as a fly cutter just to clean up the top surface. So I've got that set to 0.3 of a mil depth of cut. So that didn't clean up, so I'm going to take another pass at 0.5 of a mil depth of cut. While I've got it set up like this, I'm going to use a 16mm roughing end mill just to clean up and true both the ends. Now with that done, I'm going to clean up these sharp edges. There are many different ways you could do that, but I'm just going to use my linisher with a conditioning belt on it. Now that I've got those flipped and set back up, I'm going to use the end mill just to clean up the face that the cutter couldn't reach. Now with that done, I need to finish machining the shanks to 32mm to suit the tool height on the lathe. So I am going to machine a true spot, zero out my DRO and take a measurement to how much material needs to be removed to finish off the shanks. So that's measuring 35.5, which means I need to take off 3.5mm. Before I fly cut that to depth, I am going to come into this corner and machine the two faces, and that's also going to give me clearance for the fly cutter. Yeah, right, we're good. So you could definitely use a shell mill or an end mill to machine all these faces, but the problem with that is they generate quite a bit of heat and you would have to run coolant. And when you're trying to film when there's coolant getting around, it makes it quite difficult. So we've done this using a fly cutter. It does take a little bit longer, but we don't have to run coolant and it does leave a nice surface finish. Now with that machine to depth, I'm going to do a clean up cut on the face that's going to be the bottom of the tool holder. So that's all the machining we can do with the tool holders together. I'm going to separate them so we can do the next step. Now we've got the first holder set up, the first thing I'm going to be machining is the extension or the working area of the tool holder. So because I've got to machine 10.5mm off both sides, I will be using a shell mill and I am going to need to run coolant. I'm going to be using a 5 insert 60mm indexable shell mill. Righto, so I'm not totally impressed with the surface finish that shell mill is leaving, so for the final cut I'm going to go back to the fly cutter and make it all nice and pretty. So while it's set up on this side, I'm going to use a 12mm ball-nosed end mill to put a nice radius through that corner. Now that that side's done, we can flip it and repeat on the other side. Now with that done, I can set the tool holder up so I can machine the pocket for the insert. Now I'm just going to use the edge finder to locate the position for the inserts pocket. To mill the pocket into the tool holder, I did get a custom end mill made up that has the exact same geometry as the button inserts do. Because the inserts I'm going to be using, they are not parallel, they are tapered. Just using a standard end mill that only cuts a parallel hole would not give the insert enough support. So all I need to do is drill this down 5mm, but I don't have a digital readout on the quill, so I'm going to lock the quill in place and use the knee to lift the table to 5mm. Right, so this is probably the scariest part of the entire job. I'm going to be drilling and tapping a hole for a 3.5mm screw that holds down the insert. So I actually had to order in the taps and the drill for this. I don't have anything that small. What I'm going to do first is drill down with a 2.9mm drill. I'm also going to chamfer the top of the hole just to help the tap get started in the center. So to thread the hole, I'm going to be using two different types of taps. One is a starting tap to get the thread started. Then I'm going to use a finishing tap to fully form the thread. Normally I would use a gun tap or a spiral tap. Unfortunately, they are not available, so I do have to do this in 2 steps. This tooling is extremely small. This does make me very nervous. I'm used to working on big equipment with big drills and big taps. I am quite heavy-handed, so I'm very concerned I could snap this tap in this hole. pull it and clear it. Right, so that was very successful. We've got the hole drilled and tapped to depth. The screw fits in very nicely. I think we're good. So the next thing I need to do is take this back out of the vise and set it up so I can cut a radius across the front to give the insert some relief.
Okay. Oh, jeez. No, just wait. Hey, oh, you want that one? Hang on a minute. Sit. Good boy.
Righto guys, so that's our tool holders completed. I've gone through and deburred them and also fitted the inserts. The inserts fit perfectly and I'm really happy with how everything turned out. I'm probably going to send these out to be nitrided just so they've got a nice clean surface finish. But there's only one way to find out how well these work, and that's to put one to the test. And we're going to be testing it on removing the eye off an EX1900 bucket cylinder rod. So this is a 150mm diameter rod. With the standard tool, I would have to relief cut either side of the tool in order to get the depth that I needed. So this is going to be a really good test to see how this performs. Righto, so that performed absolutely perfectly. We didn't have any chatter or any vibration issues. I was just plunging straight in. I was moving it left to right about 1/2 mil, so I wasn't overloading the insert, but that really ate that material. And you can see there was plenty of clearance between the eye rotating and the top slide and the tool post. When you're using a standard tool holder, everything is much closer to the job, and it could be a lot easier to have a collision if you're not aware about what's going on around it. So by having that extra length, that gives me a great deal more space where I don't have to worry about it. So the tool holder performed a lot better than I actually expected it to because of the length of it and what I'm asking it to do. It is quite a lot of load to be putting on a tool. There are a few things I would change if I ever remade these. I would make it slightly longer so it was the exact same length as the tool holder, and I would probably shorten the bottom of it just a little bit so it was level with the bottom of the tool holder. But other than that, I'm really happy with how they came out. This is just going to make these sort of jobs that we do so much easier. So for a couple of hours of time and about $60 in material, these were well worth the investment. Yes, I did have to buy in some specialized tooling, but I am going to be using that on a big custom cutter that I need to make in the future. So I still need to send these out for nitriding, but that's this job done. Thanks for watching. This performs very similar to a parting blade, the way you can just plunge it in. So I think I'm going to call this a button blade. So I have modified tool holders. So I have modified. But an ongoing problem I've been... But an ongoing problem that I've... But an ongoing problem that I seem to... But an ongoing problem I've had... What'd you say? So I'm going to... Now with that done, oh fuck, what'd you say?
Curtis has got it.
What'd you say? I was just able to plunge straight in, just move left to right just a little bit just to give the tool, just using a twanded, just moving at, fuck me. Fuck off, crane. You are,
Malfunction. You can see when it started to get hot. Pretty. That is bloody close. Look how close that is. Ooh.
bang!
Oh, you're a wanker. Is that it or one more?
I need to see.
Oh. That shirt is not in good shape.
I think I'm due for some new ones.
It even made a cute sound.
I feel like I'm making watches.
Did that do anything?
Don't know, I'm not willing to
I feel
gamble
like
anymore.
I can't even see
I can't
in there.
feel anything.
Oh. What? Why would you go there?
You didn't give me direction.
Oh jeez. Spin it. No, no. What? What? Spin it. What does that mean to you?
Spin? Spin. There's a fucking bird. They both up there?
I think. Oh, yeah. I can see the other one outside.
There it comes. We're going this way.
There they go. Where'd the other one go? I thought I saw him fly past. Oh, there he is. He's right there.
Come here. Hey. Oh, you missed out. Okay. Very good.